from here, dy square, d square y, dx square equals to e to the power y. Okay, and then solve it. Okay. So that is, it looks like a standard potential problem in physics. Yes. So if you treat x like t time, and v is y is just a position, right? Then d square y dx square becomes an acceleration, right? An acceleration equals to a given function of a position, that is like a potential problem. It's like acceleration given by a certain force that depends on position, right? That's pretty much a standard Newtonian mechanics problem, right? The way to solve it is, I mean, the easiest way would be to get to the energy conservation first. And energy conservation, to get the energy conservation, you basically multiply space here. Oh, maybe too much. Not capture everything. Okay. So let's multiply this equation by dy dx, right? And d square y dx square equals to dy dx into the right. And now that this one you can write like 1/2 of dx of dy dx square, right? Dy dx now it becomes like velocity, right? This velocity square, 1/2 velocity square. That's like the kinetic energy, right? And then you ddt is like dt time derivative, and the right hand side is simply ddx of dy, right? That's what the chain rule, the dt. The derivative of that give you this one, and then take the derivative of the argument, right? And now both sides are total derivative, that they can integrate out with a constant. So it means 1/2 of dy dx square equals to ey plus a constant. Okay, and now this constant is determined by initial condition and things like that. Right? In principle, now you can solve for dy dx. Is just solve this equation. So you have 2 of ey c, and take the square root and take the square root, but then there possibility that plus and minus sign, right? And now this is separable. This equation, or this is just a function of y, and then you can say dx is equals to integrating dy plus c. So you can integrate it out and get x as a function of y in principle, right? Although this is not a standard form, I don't think you have a closed form for this one, but I don't know. You can look that up and try the online integrators. You get anything out, but and so you integrate that out, right? And you get x equals to that plus a constant, or plus a constant, another constant, right? now you have two constants, your C and C sub 1, and now you get, you need the initial condition, and most likely the initial condition, because there's a possibility that that one may even be negative, right? So you need to be a little careful about that. Right? It depends on the initial conditions, whatever that is. It's like a conservation energy. Right up to here is a conservation energy. So obviously, that require this to be positive enough. The C will make it positive. This is positive either way, but then the C will make sure that it's positive. So if initial velocity is given to you, then this is set, and C is set, right? Whatever velocity dy dx given to you at initially, the time equals 0, then C is just initial velocity or initial energy minus this potential e to the y, right? And that will give you the C constancy, but then there's a plus or minus choice sign. So it depends on the function x, and that's y, right? It depends on the sign of the velocity initially, dy dx or whatever that at t equals 0 depends on. I mean, the position may or may not given to you. So say if you given to you a certain positive one, but then even give you a speed, then there's still a possibility that it go up or go down, right? So that is the choice of your sign. If initially it's given by a positive sign, right, then you choose the positive sign, right? Because dy dx initially you set C, but then you choose the plus sign instead of the negative sign, and then you just look at this relationship. In that case, if it's e to the y, as you keep going, then pretty sure that this is increasing function of y, and y is still also increasing, then this whole thing grow up infinity, or may not be singular, but keep growing up, right? That's this case. But if initially it's given by a negative slope, if this is negative, you choose the negative sign, right? And so dy dx is decreasing and decreasing up to a certain point, supposedly. Y will decreasing, will decrease to 0, and it's 1 plus c. It depends on what the initial constant is, or initial velocity is. So somewhere along the line, it may turn around. So if c is less, it's negative, and then it's less than 1. So somewhere before it goes to 1, or y goes to 0, then this becomes 0. And so you choose a negative sign until dy dx is 0. This becomes minimum, and so dy dx becomes 0, and then you need to match to the plus branch, your minus branch, and change to a plus branch. Right? And now this, as it's move past the minimum, now this the first situation apply, the dy dx keep increasing, and e to the y keep increasing, and then it will. Depends. So exactly the how the solution behave depends on initial conditions. It's okay. That's the consideration. I mean, for this problem, it's just recognition that the equation represent what a familiar physical situation that you likely have learned. Part of the math physics is to train you that to recognize we learn math method and equation and all that in an abstract way, but then you try to match that with physical situation to help help you solve physics problem.
That should be integrated.
Say that again.
Should be integrated function.
Which one is negative?
The last version.
This one?
Yeah, it should be integrated.
You are pressed. I mean, I'm just writing it formally. The exact choice, exact one, like for this case, you actually need both. You need to choose your sign, but then somewhere along the line, you can change sign. Right? Like here, you keep decreasing until you get to a minimum, then you change sign. So over this range, you choose the negative sign because dy dx obviously is negative, right? And then up, when it goes to 0 and this argument is 0, they turn around and becomes positive. Then you choose the positive sign. So it's not exactly one equation. So this like a piecewise equation. The one range of x, you choose the plus or minus sign, the other choose the other sign. So it depends on the initial concept. You need to analyze the situation in a little more details to see, because once you have this possible choice, you need to look at the situation, which choice is applying to which situation. Is that okay?